This one is a Hall effect sensor. So a Hall effect sensor works using magnetism. So I have a small magnet here. As I bring the magnet close, actually there's a handy little LED which comes on, so I can see that the magnet is close. And this could be a wheel sensor, so the magnet can be on the wheel and you've got this connected to the chassis. And of course you can have any number of magnets on the wheel to increase the resolution if you like. So what I've got here is I've got the pins connected to ground and positive 5 volts, and then I've got an input and it goes to pin 2. Okay, so which way round do these pins go? Right, let's have a look at a data sheet. So Hall sensor. Have a look at RS online, that's the actual sensor itself. Technical reference. Okay, it says it can operate 3.8 to 30 volts DC. That's nice, nice range. But what I'm interested in is the pin out data. Okay, so it's a bit hard to see. So you can ignore most of the rest of the data sheet, but you can see there that it's got a little diagram of the chip. You've got a plus on the left, minus in the middle, and out on the right. So those are the pins. So that relates to this pin, this here. If I turn it this way round, I don't know if you can see it very well, but it is fluted. It has the edges there, so you can see that that relates to those pins there. So you know which connections they are. Okay, so in its essence, I could just connect a magnet to it and it will make the pin go high and low. However, because the magnet would be moving quite quickly past the wheel, and you might be doing something else in the meantime with the robot program. You might be measuring distance or using one of the other sensors I speak about. You can connect digital pin 2 of an Arduino Uno, and it has to be digital pin 2, or I think all 3 as well, as an input. I've actually put it as a pull-up, okay? It's got a small pull-up resistor that we can use. I don't think we have to do that. I've created a terminal, serial begin, and the command here, attach interrupt, to which pin? Digital pin 2. What does it call? It calls a function called count. And when does it call it? When that pin changes state. I tend to find that change works quite well. So it calls a function called count. So here there is a function called count. What does it do? It increases the value of counter by 1. Counter plus plus is a geeky way of writing increase the value of counter. In my main program, it's not doing anything at all really. All it's doing is printing that value of counter. Notice that in my main program, it's not actually reading the pin, digital pin 2. But in the setup, because I attached an interrupt, it's almost like that function is in the background. So I've attached to the interrupt. So that means every time that that pin 2 changes, it will jump to that function, no matter what it's doing. So it's a very fast way of being able to count a digital pin. So I'm just going to upload that and open up a terminal so we can see what's going on. Okay, so we've got a load of zeros at the moment. What I'm going to do is move the magnet. And as I move the magnet in and out of it, it counts 1 each time. So what I'm doing is I'm just simply moving the magnet close to it so the little LED comes on there. Now that would obviously be moved by a wheel, or it could be counting drill pulse revolutions, etc. It's a very strong magnet. It's just stuck onto the screw there. So every time I move that, it increases the number there. So that could be wheel revolutions. If you wanted to count the speed of revolution, you could just use a delay or a millisecond timer and count number of changes over a specific time.